Integral of Clausen function, integral from 0 to pi of CL of m theta theta. We already know its definition because we have been doing all the properties, identities, derivative, interderivative of this function in our channel previously, and we are continuing on that. It's defined in two ways, just like C numbers are modulus function. If in the two cases are when m is even and m is odd, m is even and m is odd. When m is even, it's defined as the sum from k equals to 1 to infinity of sine of k theta by k to the power m. When m is odd, it's defined as sum from k equals to 1 to infinity of cos k theta by k to the power m. Yes. Now, let's solve this integral. Definitely, we have to solve this in two parts because the definition is also in two different cases. When m odd, when m even. Okay, good. Now, m is odd. It's integral from 0 to pi of sum from k equals to 1 to infinity of cos k theta by k to the power m d theta. Now we can represent the sum and integral from the dominator convergence theorem. Yes, and we get sum from k equals to 1 to infinity. For integral, k is constant, so 1 by k to the power m. Integral from 0 to pi of cos k theta d theta. You know the integral of cos k theta, it's pretty easy. It seems like the integral is going to be solved sooner. Sum from k equals to 1 to infinity 1 by k to the power m. That's just sine of k theta by k and going from 0 to pi. We know that sine of pi k is always just 0 and sine of 0 theta is also 0. This is pretty easy. This was just pretty easy. Sum of equal from infinity 1 by k to the power m at both sides it's just 0 and 0, 0 minus 0. So the answer is 0 when m is odd. But now let's look at the other case when m is even. Sum is slightly different. The definition now becomes sum from k equals to 1 to infinity sine of k theta by k to the power m d theta. Yes, now we can integrate sum and integral as always, and then if we integrate the sum and integral, sum from k equals to 1 to infinity, and this is just constant for integral, so we can take it out. Now its integral will be minus cos k theta by k going from 0 to pi. Yes, now this is sum from k equals to 1 to infinity. Now this is 1 by k to the power m plus 1. Yeah. Now cos of 1 pi is negative, 2 pi is plus 1, 3 pi is minus 1, so it's minus 1 by k, but because here it's minus sign as well, so it's minus 1 to the power k plus 1, and minus minus is plus, cos of 0 is 1. Now it seems like we will have something. Now, what will we have? So it seems like we are going to have two different sums. A sum where this is just a zeta sum actually. Yeah, this is just Riemann zeta sum. And over here, if these are two different sums, in the first sum we will just have the odd terms. I guess yeah, just the one to the power one, 1 by 1 to the power 1 by 3 to the power m plus 1, 1 by 5 to the power m plus 1. Yes, and for even terms, it's going to negative. It's going to be like this. So 1 by 1 to the power m minus 1 by 2 to the power m plus 1. Sorry, let me read it again. 1 by 1 to the power m plus 1 minus 1 by 2 to the power m plus 1 plus 1 by 3 to the power m plus 1 minus 1 by 4 to the power m plus 1. So it goes like this. Yeah. And that is just defined as the eta function of m plus 1. And plus the other, when it's 1, this is defined as zeta function. Sorry. Zeta function of m plus 1. Now we know that this eta function is defined as 1 minus 2 by 2 to the power s, s is m plus 1 over here, of zeta m plus 1 plus zeta of m plus 1. Yes. So our answer eventually becomes zeta m plus 1, and then this is just 2 minus 1 by 2 to the power m. Yes. So this will be zeta m plus 1 over here. This is 2 to the power m plus 1 minus 1 by 2 to the power m. This seems to be the answer for me. Let me check it first before I really end the video, and then that will be it. So if I check the answer, yes, I'm actually correct. Okay, so that's the answer. Yeah, I don't think you have any confusion in this step because in this step, what I've actually done is to just break this into two sums. Sum from k equals to 1 to infinity of minus 1 to the power k plus 1 by k to the power m plus 1. And then the other sum was sum from k equals to 1 to infinity of 1 by k to the power m plus 1. And now we know that this is the zeta function, this is the zeta function. And the input is this m plus 1. Yes. So this was the solution. And we saw that through the definition, we just had to make two cases. The first case was easily solved. The first case was easily solved after just using the definition because we got 0, 0. Second case, we had to use functions like zeta and eta, and at last we did get the answer as we expected. So that was it. Hope you enjoyed the video. Thanks for watching and look forward to seeing you in upcoming videos of Clausen functions, such as Laplace transform of Clausen functions and Clausen integral functions and many more. Hope to see you there. Thanks for watching and look forward to seeing you in the upcoming video.